they give you a piece of information, right? And this is harder by virtue of the fact that it's just algebra, really? There's a bit of a shift happening here, but just because that's not a number, our brain's going to do something funny and think like, I was kind of familiar with this when it was 3 over 5 or 5 on 13 or something like that. This makes us spin out a little bit. It is no more difficult, but you will have to kind of bring together a lot of the knowledge that we've developed over the last few lessons. Okay. So here's my first suggestion. Tan theta plus 90. Okay. Tan's a bit hard to work with, okay, because tan itself is what we'll cover this later in this lesson. It's an identity, right? It's sine over cos. So bringing it back to that will be helpful. So let's do that. It's sine theta plus 90 on cos theta plus 90. Okay. So the reason why this is good is because we're much more familiar with what happens to sine and cos as we shift it back and forth. We in fact looked at some of these exact graphs earlier. Friday, Monday? We have looked at it in recent times, but it's okay. I'm not assuming that you know exactly what these look like straight away. I pause, even after having looked at this for a long time, to think, wait, which one is it exactly? It's not that hard to work out though. Let's just do a really quick graph of sine, and then we'll do the appropriate shift, right? So here's what sine looks like. Okay, now it's 90 degrees, it's a plus 90 degrees, so what direction am I going in?
Left.
Left, right, left. So I'm going that way, 90 degrees. Now, there's 90, right? So see that point there where it goes to the top? That should be on the axis, so I'm getting this. Okay, I've shifted it, I recognize that, that's cosine. So I'll slap that on the top. Okay, now I've got cos of theta plus 90, and I'm just going to repeat the same process, right? Eventually you'll start to get to the point where you don't need to do this. You can start to do it in here. This is still fairly new to us. So here is cos, and again, I've shifted it 90 degrees to the left. So what's it going to look like? I think that's what we're having, right? You can see this crest over here is moved. This intercept has moved to the origin. So is that okay? So what is this thing? It's negative. It's minus sine, right? So minus sine theta. Okay. Now the question was, can you evaluate what this tan blah 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 is in terms of k, right? So I've clearly made some progress here because I have sine theta and I know what sine theta is. Okay. So I can substitute that in a second. I might as well go all from thetas to all k's all in one fell swoop if I can. Okay, so in our previous questions, like if I said to you sine theta equals 3 over 5, and I told you theta was, well, theta's obtuse. Okay, so let's just go with that, right? How would you work out cos theta? What steps would you go through?
Draw a triangle.
Okay, so on the Cartesian plane, in the second quadrant, I will draw a triangle, okay? And it goes over here, right? There's our related angle for theta, our kind of theta. Opposite on hypotenuse, there's the adjacent. So there's cos, it's negative 4 on 5. Happy? Alright, now I can't do this with numbers because I've got algebra, but it works just the same, doesn't it? Instead of 3 and 5, hold on. These are all different now. I'm still in the same quadrant. It's still sine. So what numbers and letters should I put where? Suggestions?
Wait, it's like k on 1.
Yeah, see, this is a ratio in disguise, isn't it? It's k over 1, right? And that's your opposite and your hypotenuse. My opposite and my hypotenuse, okay? So at this point, you can now see, by Pythagoras, and you don't need to labor it, that side there is the square root of 1 minus k squared. And this is adjacent over hypotenuse. Adjacent over hypotenuse. So now I have cos, okay? One more thing to note, because cos is theta is obtuse, and I'm in the second quadrant, that square root actually has a minus sign out the front, right? Because I'm going to the left of the axis. So this should be minus the square root of 1 minus k squared over minus k. You happy with that? 2 minus signs. And I'm home. Okay, so does it make sense? Do you agree?
Wait. You got that. So what does it prove?
Okay, so what have I done? I have changed from one variable, theta, to another one. Okay? At the moment, what's the relevance of that? We're sort of leading towards when we're going to have all kinds of different functions and we want to translate. In a similar way to why we want to translate from cos to sine or vice versa. It's like, well, if I know vertical movement, I can work out horizontal movement. In the same way, this kind of changing of variables will become very, very useful to us later. Okay?